So today's topic is using timelines to do more complicated compound growth calculations. And what makes compound growth calculations more complicated? Well, what we can do is instead of having all the interest rates stay the same, the interest rates can change, or I can change. We can also change when we put money into the bank account or withdraw money. And so we need a systematic way of laying this out. The good news is there's a very, very easy way of doing it. And I just want to start by introducing you to that today. So here's the first question. And the way I do it is I look through it and I look for the key information. So it says, maybe I'll highlight it, Thabo invested 1,000 Rand in a bank for 10 years. So it seems like this question is based on the time period of 10 years. The interest rate was 6.5% compounded quarterly for 3 years. So that's kind of important. For the next 5 years, the interest rate was calculated at that. And then for the remainder, the interest was compounded like that. And then the final question is, how much money would Thabo get at the end of the investment? Now, there's a lot of detail in the question. And so what we need to do is take the information, which is currently in scary words, and put it into a diagram. And this is what I think we should do. What are the periods that are important in the journey of this money? Well, T0 is the beginning and T10 is the end of 10 years. Give me a thumbs up if you're happy that that represents reality from the question, that the game goes down between T0 and T10. And all the timeline is taking information that is in words and putting it into a visual. Now, if we look at important periods along the journey, the interest rate was a certain amount for the first 3 years. So what I'm going to do is on my timeline, I'm going to make a special point for T3 because that was where something changed. And then for the next 5 years, well, the next 5 years after 3, that's going to get me up to T8. And then for the remainder is just going to be the time between T8 and T10. So again, give me a thumbs up if you understand why the T3 and T8 are important. Specific things change on the journey at those points. Okay, so again, we're taking all this rather detailed information and we're putting it into a simple representation. Let's look at the interest rate. Between T0 and T3, I'm going to put a squiggle. And I'm going to say the interest rate in this time period was 0.065, but I'm not going to leave it at that. What do I need to do to this interest rate to make it match what's going on in the question? It's not a 6.5% per year interest rate. It's 6.5% compounded quarterly. What does that mean about this interest rate based on the last lesson? Yeah. Bongokosi, I couldn't have said it better. You divide it by 4. Pomelo, absolutely. So the good news is the blue thing tells us the interest rate in that time period. Now, I want to know what is the interest rate between this time period. And following the same idea, it's going to be 0.72 divided by something. And the something is going to be 12 because it was compounded monthly. So I'm chopping the interest rate from a yearly interest rate into a monthly interest rate. So I've got the first. Now the last bit, I do a squiggly line and I say, what is the interest rate here? Well, following the logic of what we've done, 0.78. And because it's semi-annually, I'm going to divide it by 2. So we have now put the key time periods on the timeline. We've also put what interest rates are applicable. Give me a thumbs up if you understand how this drawing represents the information over here in an easier to read format. Now, there's one important thing we've left out. What have we left out, not spoken about at all so far? What do you think at some point I need to deal with? It's all good and well drawing pretty pictures, Mr. S, but what do I really have to do in this question? Number of years, yes, you have to go from 0 to 10. I was thinking I haven't spoken about the 1,000 Rand in the bank account. So at the bottom here, I am going to put 1,000 in line with T0. So that 1,000 needs to go through a journey. The first journey it needs to do is it needs to go till here. Then once it gets to here, we have to change a little something about how it grows, and it grows all the way up to here. And then the very last bit is this 1,000 has to grow through here all the way up to there. And then the 1,000 will be whatever it's meant to be. Now, how do we do the growing? Well, the growing has to be done using the compound interest formula. So let's start with this. If I have 1,000 Rand in the bank account, and I just want to grow for the blue part, the first 3 years, all I'm going to do is I'm going to use that interest rate. What is the number of time periods going to be for that first blue bit of growing? So it's 3 years, but I don't want it in years because my interest rate is in quarters, or quarters of the year. So how many quarters of a year are there in 3 years? And I can see in Kazi and Bongwe, people are getting that this is 12. Yes, fantastic. Now, get me a value for that. What amount of money is sitting in the bank account at that point? It's going to be here. Pop it in your calculators and see what you get. So in Paul and in Bongwe, okay, lots of students are getting 1213.41. Now, here's the sneaky thing. We're not done. So instead of putting that amount down, all we do is we pretend that this amount is the amount that we need to use as the p-value for the green bit. So how does that work? Well, what we do is we open up another bracket and we treat this first bit as if it's the p-value or the input value in the calculation. But you need a bit more. So what's going to go here in this fraction that I've left out now? What's going to go in the fraction there? That's going to be the next bit of journey from the interest rate between the 3rd and the 8th year. And what is going to be the time periods? So how long does it take in months to go from T3 to T8? Well, 5 times 12 will give me 60. So if I multiply 1,000 by the blue thing and then multiply it by the green thing, I will get to how much money is in the end of the 8th year. But that is not what I want. I want to know what is the amount in the bank account at the end of 10 years. So what I pretend is that the bit that's underlined is the p-value, and the last bit is the growing for 2 years here. And this is just going to be what I love about the timeline idea is you just grab the interest rate from here, and the thinking has to be done with what is inside the red square. So if you look at how the interest rate is compounded for the last 2 years, how many of those periods are there between 8 and 10? So 2 years, but if you're going in half years, they're going to be 4 half years. Awesome. Now, this is awesome. What isn't so awesome is putting it in your calculator. So I'm going to give you a little trick. What you do is in your calculator, you type 1,000 times the blue bit, and then you hit equals. And then you're going to get a number. And then you go times whatever you've got, 1 plus whatever, and you hit equals again. And then you go times the red bit, and you hit equals again. Now, what that does is it means that you leave less stuff on your screen, and it just gets less complicated to actually get a value. So tell me what is sitting in this bank account after 10 years if you use this, yeah. Okay. No problem, Ashton. Totally. What curriculum are you doing? Just for, I'm curious to know what, just to check. Okay. So what we are getting is we're getting 2024.64. And so the 1,000 Rand that started has grown all the way to 2024.64. Oh, caps. Okay, actually, maybe you haven't covered financial maths yet. That could be the thing. Okay, because it is in caps. The financial maths is in caps. But yeah, no problem. You can. Well. Okay, let's do a practice one of this. Let's go and do this old exam question. I want you to start by drawing up a timeline for this old exam question. And then once you've drawn the timeline, say done. And then we'll check that our timelines work, and then you will find me the answer after that. But first, draw me a timeline for this question's information. Be back in a moment. Let's need some water. Ah. Now, what maybe is a little bit tricky is I would have T 1.5 because 18 months is 1.5. And I like to keep it in years. It's a bit easier. Now, you need to think what interest rates go on to what parts. Let's use these two colors. Let me use that. So here the I would equal 0.09 semi-annually, so divided by 2, and then 0.075 divided by what? 12 would be the interest rate here. Sometimes you see some textbooks say I equals. So we know that we're going to use the compound growth formula to help us. What we haven't done is the amount of money that we start with at T0 should be 14,000. And this 1,000 has to grow to here. And once it's grown to here, it then has to grow some more to get all the way to there. I will start you out by writing this. I want you to fill out the next 2 blocks and then get me an answer for how much my 14,000 grows to. And if I'm going too fast, please put your hand up and ask a question. I'd be happy to engage with you, but at the moment I'm seeing things as being okay. We kind of actually know what's going to go in here. It's just going to be probably the trickier part is knowing what the numbers should be. Now, this is dealing in half years. How many half years are there in a year and a half? Well, they're going to be 3. Because 6 months, 6 months, 6 months gets me to 18 months. And then here there are months, and there's 3.5 years. So 12, 12, 12. There's 36 months in 3 years, but there's another half year. So plus 6, and so this should be 42. So here, the n should be 3, and here the n should be 36. But remember, this is 36. Sorry, not 36. This is 42 months, and this is 3 half years or semi-annuals. What do we get if we put this in? Now remember, in your calculator, you go 14,000 times this to the power of 3, hit equals, and then go times this bit and go equals again. So you want to make sure that you give yourself a chance to, otherwise you end up seeing too many things on the screen and your calculator gets stressed. And you don't want to stress your calculator out. You want to treat it with TLC so that it treats you well too. Close to the power of 3, and then I'm hitting equals. I got 15976.32 and so on, and then I go times open bracket 1 plus fraction 0.075 over 12 close bracket to the power of 42, and I get 2755.08 rands. Give me a thumbs up if you felt okay with that. Give me a thumbs down if you felt unsure about something. Okay. So what I'm going to do as the last question before the break is I'm going to take the same ideas, but just mix them in a slightly different way. And then you're not sure. Seni says, I'm not sure about the 18 months. Okay. So 18 months is a year and a half. And the reason 18 months is a year and a half, I've written it like that, is that the timeline is in a year scale, but dealing with the interest, it has to be in semi-annuals, because I've taken the yearly rate and divided it into 6-month periods. So I want to know how many 6-month periods are there in 1.5 years. Well, there's 3 6-month periods in 1.5 years. Whereas when I go to the next one, there I want to know about months. And how many months are in 3.5 years? Well, it's going to be 12, 12, 12, and then 6 for the half. Okay, let's do another one. One more before the break. Now, this one is slightly different because it actually uses simple interest to start with. So it says you've got this amount of money and it's invested for 4 years. So your T0 and T4 are there. But what happens next is for the first year, the investment grows at simple interest rate of 11% per annum. And then at a rate of 12.5% compounded quarterly for the rest of the period. So I want you to start by drawing your timeline and then filling in the bits of information. Now, what's important, let's just do that first. First of all, do your timeline and say done when you've done your timeline, and then we'll talk about how do we grow something with simple interest, how do we grow it with compound interest. Okay, so as we look at our timeline, we should have black time value things at T0, T1, and T4. And then for the squiggles, we should have our interest rate at 11% per year. So I've divided by 1, but it's essentially 0.11. And then for the blue one, it's 0.125 divided by 4 because it's compounded quarterly. And so quarterly means I need to chop it up into quarters. Here's my 5,500. Now, what's different here is I'm going to grow this, first of all, with the simple interest. So I've got A equals 5,500. And instead of having the one with the power in the sky, I'm just going to have for this bit 1 plus 0.11 times 1, because it's 1 year. What do you get for that amount? So basically, I'm getting to that point and saying, how much money do I have in my bank account at that point? Okay, so you're correctly seeing that you have 6,105, but you're not done. You still need that 6,105 to grow for a little bit more time. Why did I say 1 instead of 12? Kumalo, in here, it says a simple interest rate of 11% per annum. And so it only grew for the first year at simple interest. So the first year is from T0 to T1. And the interest rate for that first year is 11% per year. So there's just an 11% sitting here that applies to the 5,500 for the first year. And I've used the simple interest formula because it said to me, use the simple interest rate. But now in the next bit, I have to grow all the way along here. And so this bit is the input. I'm going to have another bracket where I go 1 plus 0.125 over 4, because this is the interest rate per quarter. What is going to be up here as a power, you think? So you're going from the end of year 1 to the end of year 4. How many quarters are there? So you have, I see the answers coming in now, 3 years, but I don't want 3. I want 3 times 4, which is 12, because it grows for 12 quarters in those 3 years. So what is my final answer going to be? I do the first bit, I hit equals, and then I times it by the blue bit. What is my answer for the end of the 4 years? How much money is sitting in the bank account? I see that Teboho and Trishan and Puti have all put answers in, and they get 8831.88. We can even check the answer down here, but that looks very correct to me. 8831.88. Absolutely. Okay, everyone, thumbs up if you're feeling good, thumbs down if you're feeling unsure or uncertain about something. Turn off one is mine. Fantastic. Well, I think we've earned a break. So what I want you to do, wait, is there a hand? Okay. Let's have a break. So let's get to our feet and just take a moment to just unwind and just, give our bodies a break. So let's just start with a nice deep breath and hold. So that's 1. Let's do 1 more. Oh, that feels so nice. Okay, then let's shake our arms out a little bit, get nice and mellow. Check out our feet and our legs. Get nice and loose. Let's rotate a little bit from our hips. And just start nice and slowly. And then as you feel your body relaxing, you can go a little bit further. You can definitely feel like I played tennis today. Oh, my legs are stiff. Okay, then let's roll our shoulders back. Roll our shoulders forward. Let's do a tricep stretch. And just hold it. And switch to the other one. Oh, and then shake it out again. Okay, let's just get our hearts pumping a bit of blood to the rest of our body, including our brains, hopefully. And we're just going to do some air skipping, and we'll start in 3, 2, 1. Let's go. Five more. And yeah, I hope your body and brain are feeling a bit freed. Let's have a look at a Maths 24 puzzle just to... So here are your 3 Maths 24 puzzles for today. If you can solve them, then the glory is yours. And you can pop your answers in the chat. I think so, Sian. Tati, yep, you got that first one, chop chop. 7 plus 7 plus 4 plus 6, 24. Oh, there's another way. And Paul said 6 times 4 times 7 minus, wait, no, 6, yeah, plus 6 times 4 plus 7. Or you could have said 6 times 4 times 7 divided by 7. Those will all give you 24. Nice. Okay, red is gone. The glory has been handed out. What about the blue and the yellow? This is a 6, in case you're wondering. So, Ndile has said 5 plus 6 is 11. Times 2 is 2, plus 2 is 24. Looks also to 5 minus 2 over 2, which is 5 minus 1, which is 4, times 6, which is 24. And Emmanuel has said, oh, there's lots of ways of doing this. 6 plus 2 is 8, and 5 2 is 3, and so that would be 8 times 3, which is 24. Look at you guys, just bringing out solutions out of nowhere. Okay, what about the yellow? Can we finish off the puzzles for today? Who can solve the yellow puzzle to get to 24? Oh, what happened there? Nine, 7, 8, and 2. So what is Kitsor? Kitsor has made the suggestion. So 2 times 7 is 14. Oh, wait. Oh, I see what you're doing. Okay. 7 plus 9 is 16. Then what we have is we have times by 2, which gives me 32, minus 8, which gives me 24. Yes, it does. Anyone else have any ideas? But I think that is That's definitely the way of doing it. Are there any other ones? Okay. Okay, well done, everyone. That was good work on the puzzles for today. And let's finish off with a strong second half around timelines. So what else can we do to make things a little more exciting? Well, let's have a look at this question. So it says, Susan deposited 5,500 into a savings account. 5 years later, she deposited another 4,000. Interest for the first 3 years was 14% per annum compounded semi-annually. Thereafter, it changed to monthly. How much money does Susan have at the end of 7 years? Now, what is different to this, although the methods we use won't be that different, is that there are two things that are deposited. There's the original amount, which is 5,500, and then later on, another 4,000 gets kind of put into the bank account. And this would happen in the real world. We all know that at different times, sometimes we make some money or we get given some money and we can save them. And the interest we get will be different depending on when we put the money into the bank account. Now, the good news is this is actually super easy. But before we do that, forget about the 4,000 and 5,500. Draw for me a timeline with all the key information on it. And once the key information is there, I will talk to you about how we handle the 4,000 and the 5,500. And just tell me, just say done in the chat when you've put the key information for this question. That's T0. And that's T7. So I think those are the important ones, T0, T3, and T7. So what do we think the red interest rate is going to be? What do we think the green one is going to be? Because the interest rates do change. Let's go look. For the first 3 years, compounded semi-annually. So I go 0.14 divided by 2. And then we have 0.12 divided by 12. So at this point, I have ignored the amounts of money that have to grow. I just wanted to know what are the important periods at which the interest rates change. But at some point, I need to bring in to account the money. And so what I'm going to do is I'm going to say plus 5,500. And that amount has to grow for all 7 years. But then below that, not in the same line, in line with, where does it say? 5 years later, she deposits. So in line with roughly where T5 would be, I'm going to put a plus 4,000 because that's when it's being added. And I'm going to put above it a T5. Now, what's very clever about handling this is you are going to keep these two amounts separate. So the 5,000 has to grow until here using the red way, and then it has to grow for more time using the green way. The 4,000 only has to grow using the green interest rate. So give me a thumbs up if you follow the logic that I'm using here. So I'm keeping the 5,500 and the 4,000 separate because the 5,500 has a much longer time to grow than the 4,000. And so it's very clear what has to grow for how long. Question. I see a good question. Sate, let's unmute you. What is your question?
So
Hi,
I wanted to know, can you hear me?
Yeah, perfectly. Go for it.
Okay. So the question with my understanding, it says that student deposits 5,000, right?
Yeah.
And then without any interest.
Yeah. So at the
And
very beginning, it's just the 5,000. If you can hear me, my internet is being a bit difficult. Apologies, Satya. I don't know if you can maybe put your question in the chat. But what we're going to do now is we're going to let the 5,500 grow. And I want you guys to fill out where you think is going to be in the red brackets. And then I want you to fill out what you think is going to be in the green brackets. And that is just going to be the 5,500. Then once you've done that, you're going to have a separate little bit for growing the 4,000 and using the visual of the thing here, you need to figure out what goes there. So I want to give you some time now to think about what goes in each of these blocks. Notice how the 4,000 is on its own journey, but it gets added together at the end. And then I want you to try and get, what do you think is the amount in the end that we end up with? What's inside the red block, the red square? Yep. So it's half years. How many half years? There are going to be 6 half years here. And how many months from T3 to T7? 4 years. 4 times 12 should be 48. Now, what about how long does the 4,000 have to grow? In terms of the interest periods, you don't want to be in years here. You want to be in months because the interest rate is in months and they have to match. So what's the last green block going to be? So Emmanuel says 12 times 2. So from T5 to T7 is 2 years, and 2 years has 2 lots of 12 months. So you would get 24. Now, to get your answer, you're going to have to do this whole thing, go equals, then go times the green stuff, go equals again, then go plus this whole thing time, plus that times that, and so on. And then you'll get a final equals. And then you'll get your final answer. And that way you don't have to type everything in and make silly mistakes. You just go equals, and then you keep carrying the bag to the end. And I want to see what students end up with as the final amount of money after 7 years. So what I love about this method is that it keeps it's so elegant. It's like the 5,500, it does its thing and it grows in life. And then the 4,000 gets added to the party later on, but it also has its own row. And so I really encourage you, keep the amounts separate so you can see visually what is going on in terms of going there. Just give me a little thumbs up if you're feeling like you followed this example. I know it's a bit harder because there's 2 parts to it, but just let me know with some feedback. I'd like to do one more of these tonight. Okay, and Paul, when I say on its own journey, it's going to be in the bank account, but it's so much easier to think about the 4,000 arriving on the scene after 5 years, and all it does is it grows for those 2 years. So all the maths you have to do for the 4,000 is handled over here. Now, the other bit, it goes through the same timeline, but it has a different journey because it has to cover the first 3 years first of growing, and then it grows for 4 more years. And so that's kind of what I'm trying to get at is students, it's not wrong to put them together, but my experience is when students put them together, it gets a bit overwhelming if you're putting it all. And also there are other questions we're going to do next time where understanding why it's separate makes life a lot easier. Okay, so important. I hope that helps a little bit. You will, what I can say from experience is that this is definitely the easiest way to do it. So we are ending up with 18,386. So 18,386.28. And so from the end, if you think about it, they put 4,000 in over here, it's grown quite a lot over the time period. Is everyone okay to do one more of these for tonight? Have we got the power? Have you got the energy? Can we do one more? Come on. Let me know in the chat. Let's do it. The more you do this, the more it's like, yeah, it's not so bad. What do we have? One who's done that. Let's go and find one from. I want to find you a proper one that's a bit harder. Okay, this is a bit of a. You guys have been working hard, so we're going to go out with a good one here. So, what you have is 150,000 is deposited at the beginning, and I'm going to make this harder, not harder, but I'm going to push you guys because you are doing well here. So see if you can do this one. I want to see. In fact, I'm going to let you fly solo. I'm going to give you 3 minutes. Do what you can in terms of how you think you would lay this out. And then once you're done with the timeline, just say done. And then we'll do the timeline together, and then we'll deal with the deposits. Okay, so you do the timeline, see if you can set it up. Then once I see enough dones in the stream, I will come along and check, and then we will handle all the multiple deposits after that. I actually really like this section. I think it's such a neat, efficient way of understanding how money grows. And if you work in finance one day or accounting, you will definitely do these types of calculations all the time. That I promise you. Because people are always budgeting using compound interest calculations. That's T6. When you feel like you've got the key information on the screen, just say done in the chat. Okay, so this is 4 years at compounded, 12% per annum compounded half yearly. So this is 0.12 divided by 2. And then it changes to 0.085 compounded yearly for the rest of the period. So compounded yearly is just going to be like divide by 1, or it stays essentially the same. Now, the interest rate changes are not that hard. What is a bit tricky is we have 150,000 at the very beginning, And then what else do we have? Because other bits, a deposit of 8,000 is made into the account after the first year. So we're going to call that, say, T1. And below T1, I'm going to say plus 8,000, because that's what happens. And notice how it's on a separate row. And then another deposit is of 2,000 is made 5 years after the initial investment. So this is going to be T5, and this is going to be even on another row, and that's going to be plus 2,000. Give me a thumbs up if you understand what my drawing is telling you in terms of what is added and when it's added. Give me a thumbs down if you're not following why I've got 3 different rows. Now, what I want you to try and do is I want you to try and figure out, let's say there's actually going to be two pieces here. So there'll be a green, or sorry, there'll be let me put this in. So there'll be 150,000 has to grow for a while. Then there'll be an 8,000 that has to grow for a bit of blue. So let me put that over there, a bit of blue and a bit of green. And then how much does the T5? I think the T5, which is the 2,000, it only has to grow for the green bit. So can you figure out what goes in each of these things? And then can you figure out what the final answer will be? I'll give you a bit of time because this is, this is a decent question. This is, I've taken it up. So I want you to spend some time thinking what goes in each of those blocks and what is the final amount going to be? So I think this is going to be 8. Now that is for 2 years. And then how long does this travel for? Now that only starts in year 1, so that's got 3 years, but it's 3, how many half years are there in 3 years? And there's going to be 6. This has 2 years to grow, and it's growing in year intervals, so that's going to be 2. And then the last one, 2,000, is just going to be 1 plus. I need some more space here. Over 1, and that's going to be to the power of 1, because it's got 1 year to grow. Okay, what a mouthful. So can you get me my final answer here? Remember this, you're going to have to hit equals a lot of times. You're going to have to hit equals, punch in your calculators, hit equals. Then here, hit equals. And you go plus, you do your whole thing, equals, times that, equals, plus, and then you do all that, and you have a final equals. And I want to see what you guys get. So Emmanuel said, or Sate said, if I do the calculate the amount of accumulation of 150,000 because of the interest and after add the additional deposits after, is it okay? It is, Sate, as long as we're getting the same answers. You can add everything into the pot as you go. It's not wrong. It's just that this method, it really adapts well to money coming in and money going out. So in the next lesson, we're going to talk about what happens if we withdraw some money along the way. And if you understand where the pieces are coming from in this, it really, really helps you to Understand that. Okay. So let me just put the final answer up on the board so you can all see it. I'll move it to here. So you should be getting 296,977. And if you're a little bit confused there, all I want you to do is re-watch this last 10 minutes before the lesson on Wednesday, because yeah, like we've pushed it up a notch now, but I think you're all well capable of doing it. You just need a bit of time to let it sink in. Okay. Kia, if you could please put the quiz link, not the quiz, the poll link in the chat. Are there any final questions from students about this last one? I'll just recap. So step 1 was to make a timeline. Step 2 was to have the different amounts entering into the timeline at different points. Step 3 was to calculate how the growing happens for 150. Then the growing happens for 8,000. Then the growing happens for 2,000. And so that was kind of the process. Now, if you're feeling a bit overwhelmed by tonight's lesson, remember we are going to do the same thing in the next lesson.